Hey, what's going on, everyone? kaashmonee here. So I just wanted to talk about this little thing that I was just sort of worked on, just to play around with it or tinkle with it or whatever. But it's basically these things like these CRDTs or whatever. So so basically what these are distributed data structures that where you don't have to manually. So I think basically what I understand is that you don't have to manually do consensus, where if you have a regular distributed system and you have different data on different computers, you have to do some sort of event where, or you have to do some sort of process or explicitly do consensus. But here you can sort of I think the idea is that you can kind of avoid it and make changes locally with the assumption that your data is eventually consistent later on. So I think there's this website, CRDT.tech. So it has a lot of cool stuff about, or a lot of cool resources about how these things work. So one of the most basic, or one of the simplest ones was how it was a GCounter. Right, so it's a grow only counter. So you have so this is basically kind of describes the spec for it. And the basic idea is that you just need something that just slowly increments, and it exists on every single computer, and it updates locally, but does consensus sort of in the background and achieves eventual consistency. So it's okay, so how does this, so the question is, how does this happen, right? Or rather, not how it happens, but rather what's the point of this? Well, where would you want a counter that just increments by one? And a good example for that is where if you have a distributed web server, or a website that's served with a bunch of different nodes, like a distributed web server. And you want to count the number of visits to the website. So the number of visits to the website, obviously the user is abstracted from the underlying implementation of how the website is served. So the user doesn't really care or know. What you're looking for is a way to, every time a different user visits the site, even though it may be a different node that serves it, it still maintains the same global count, and the number of times the website has been visited is also eventually becomes consistent. So let me kind of show you what I mean. So just to sort of understand this better myself, and this is mostly just a tool to just play with and try to figure out how it works. But yeah, so now that we've looked at the background a little bit, this is the code for it. So I'll just go ahead and run it and just do a quick demo of how it works. So let's go run main.go. Oh shit, so I guess, is this already running? Somewhere it's already running? Where is it already running? Damn, so 8080 is already being used, huh? Ooh. Okay. Ooh, I don't know what's going on. Oh. This might be related to, this is probably an OBS thing. So let me just change the port real quick so that it's 8081. There we go. Cool. So you see right here that the master, or the server, initialized 10 workers, and then the start process is just a debugging statement. But basically there are 10 nodes in this thing. So in the code you'll see what happens is you send the request, and then you get a response from the server. So there's this go routine that's just always running, and it processes different requests and stuff. So for example, let's say that I want to display the number of visits. So I just get it from, I randomly choose a worker in my set of workers, which is 10 workers. So I just randomly choose an integer and go from there. And then I just I call this visit operation, which sums up the entire So since so this maintains the state. So if there are 10 nodes, each node maintains a state of all 10 nodes, right? So so that's what we're doing here. And then when we get chosen worker.value, so we can go into this function a little bit. Right, so when we go to this function, all this does is so now there's a worker thread running, and when you make a value request, this just counts up the number of views of each node, and then it sends it back, right? So yeah, and then there's also this merge operation. So like we talked about earlier, the important part about CRDTs is that you need to it needs to automatically do consensus and achieve consensus in the background. So that's what this merge operation does. And the way this works is that after this get merge duration function just sort of chooses a random duration, and then so then it sends a worker request. So basically what this does is it sends a worker request of type merge, and then it sends its payload to the master. And then once the master gets this request, right? So the master was every worker, the master is listening to every single worker, and then once the master receives this request, it then triggers a merge operation where the way you do a merge is you for each node you get the request, right, and then you take the maximum value. So send it to master request. And so the reason we send a worker request to master, so we send the worker request to master, and then if the master request is a merge, then we update all the views to be the max value of the master views. So cool. So then, okay, so now that this is running, let's take a look and see how it works. So here's a demo. So this page has one view, served by node 3, the third node. So 3 views. Okay, so it's a little buggy. So I don't actually, sometimes it increments by 2. I'm not totally sure why. But it's, I'm thinking it's supposed to be eventually consistent. So and also it's page views. So I figured, okay, it doesn't have to be totally accurate as long as it's roughly in the same ballpark, which I think in general it is. So, but I mean, it's don't get me wrong, it's still wrong, technically speaking. I think it's still a little buggy, but I also don't know how much more time I'm going to spend trying to debug this particular issue. But yeah, you'll see okay, it didn't refresh this time, or this time, but now it refreshed this time. Even though I refreshed 3 times, it should have been 7, but it missed 1 for some reason. Oh, and then okay, so it got 8. Okay, so that's interesting. So, and I think that makes sense. So when it misses, so it missed 1, it got the wrong count, -1, but then the next one, it got it right. So I think that's what this idea of eventual consistency should be. So eventually you notice that it's 12. So yeah, so I actually think this is roughly working right, which is kind of cool. Yeah, and so that's basically the demo. Cool. Yeah, thanks for watching, and you should let me know if there's anything, if you have any questions or suggestions. I'm not sure what else I could try here. I definitely don't want to make this UI but I mean, I don't know, maybe I can work on make the UI a little bit prettier, but I feel like I don't really care that much about the UI, so I might just leave it as it is. And the other thing is so this README is pretty bare, so I'm gonna update this too. Maybe I'll make another video once I do that. But yeah, I just want to update the README with sort of how I went about this. I actually use ChatGPT a lot to understand how CRDTs work, since I could just keep asking it questions and shit and tell it and ask it to I literally just said, can you give me the implementation spec of a GCounter? And it basically said okay, this is the requirements for GCounter, so which made my life a lot easier. Yeah, if I were to like read this Wikipedia article, this would definitely take a lot more time and effort to parse and really go through. But yeah, so yeah, that definitely saved me some time. I didn't use it to actually write any code or anything. Yeah, I just use it to like teach me what's going on basically. So I'll maybe also put down like my process and steps and stuff in case it's useful. But yeah, cool. Yeah. So just let me know what if you have any thoughts, and thanks for watching.